Peace be upon you, grade 8 students. At the end of this video, we are going to discuss these objectives. Most children encounter microbial diseases during their childhood, such as chickenpox, measles, and mumps. But why does a child encounter these diseases only one time during his life, although he may get infected by the same pathogens many times? This is what we are going to explain in this video. What happens when a pathogen invades our body? Our body has thousands of B cells where each one has a specific shape. When the pathogen enters our body for the first time, only the B lymphocyte, which is specific to it, recognizes the antigen and starts proliferating after the activation of T helper cells. Some of the activated B lymphocytes differentiate into plasma cells, while others will be kept as memory B cells. The plasma cells are able to secrete antibodies that neutralize the antigen. What about cytotoxic T cells? When a cell is infected by a virus, it presents pieces of its antigens on its surface. From the thousands of cytotoxic T cells that our body has, only the one that is specific to the antigen recognizes it and begins to proliferate shortly after the activation of T helper cells. Some of the activated cytotoxic cells differentiate into effector cytotoxic T cells, while others will be kept as memory cytotoxic T cells. The effector cytotoxic T cells lead to the death of the infected cell by the mechanism of cell-mediated specific immune response. A second time a chickenpox virus or any other pathogen enters your body, the immune system eliminates it quickly and you will not become sick with it. What prevents this reinfection? What are the types of the specific immune response? The specific humoral immune response or the specific cell-mediated immune response can either be primary or secondary. The primary specific immune response occurs after the first contact with an antigen, while the secondary specific immune response occurs after the second contact or more contacts with the same antigen. To study what happens during a secondary humoral specific immune response, let us remember what happens during the primary one. Upon the first exposure to an antigen, the body takes time to recognize the antigen. In this case, a certain type of B lymphocyte is activated. The B lymphocyte starts to proliferate and multiply to increase its number. But not all the multiplied B lymphocytes will be able to fight the antigen during the primary immune response. Some of the multiplied B lymphocytes will differentiate to acquire a certain role. They will differentiate into plasma cells. The plasma cells are able to produce antibodies that neutralize the antigen, while some of the multiplied B lymphocytes will be kept as memory cells. What is the role of these memory cells formed during the primary immune response? Let us see. Upon the second exposure to the same antigen, the memory cells are activated and they directly and quickly produce antibodies. These antibodies are similar to those produced during the primary immune response. So in the secondary immune response, the recognition step is skipped. That's why the secondary immune response is faster than the primary one. What about the secondary cell-mediated specific immune response? Also, there is formation of memory T cells during the primary cell-mediated specific immune response, and these memory T cells will always intervene during the secondary specific cell-mediated immune response. These memory T cells will lead to the death of the infected cell. Don't forget that the secondary immune response, the humoral and the cell-mediated one, is specific. The memory B and T lymphocytes are antigen specific. So what is the role of memory cells? The memory B and T lymphocytes, which are formed during the first contact with a pathogen, fight directly the same pathogen when it enters the body for a second time. Thus, the immune system becomes able to remember this pathogen if it enters the body again. Thus, you acquire a long-lasting immunity. What is the difference between a primary and secondary immune response? This graph shows the variation of the concentration of antibodies produced during primary and secondary immune response as a function of time. Upon the first exposure to the antigen, the concentration of antibodies remains 0, which means that antibodies are not produced because the immune system needs several days to recognize the antigen. After that, the concentration of antibodies increases to reach a maximum. Then it decreases. So what are the characteristics of the primary immune response? Excellent! The primary immune response is slow to build up because it takes time to start. And it is not very strong because there isn't very high concentration of antibodies produced. While upon the second exposure to the same antigen, the concentration of antibodies increases quickly and directly to reach a maximum. After that, it decreases. Notice that the maximum concentration of antibodies produced during the secondary immune response is greater than that produced during the primary one. So what are the characteristics of the secondary immune response? Excellent! The secondary immune response is more rapid and stronger than the primary one. The secondary immune response is more rapid than the primary one because the concentration of antibodies increases quickly and directly. And it is stronger than the primary one because the maximum concentration of antibodies produced during the secondary immune response is greater than that produced during the primary one. Why does the secondary immune response have these characteristics? Because upon the second exposure to the same antigen, the memory B cells are directly activated and produce quickly high amounts of antibodies. Now open your worksheet booklet on worksheet 10, page 33 to solve an application. In this application, you are going to deduce the characteristics of the secondary immune response and compare them with the characteristics of the primary immune response. An experiment is performed on a mouse. The mouse is injected for the first time with an antigen at time equals 0. Then, the same mouse is injected with the same antigen for the second time after 1 month. Keep in mind that the mouse will develop a primary specific immune response after the first injection with the antigen, while it will develop a secondary specific immune response after the second injection with the same antigen after 1 month. The number of B lymphocytes produced by the mouse after each injection is measured and represented in the following graph. Look, this graph has 2 curves. Let us analyze and study this graph. Upon the first contact with the antigen, that will lead to a primary immune response, and during the first 2 days, the number of B lymphocytes is 0, which means that there are no B lymphocytes during these 2 days. Why? Because it is the time taken by the first immune response and the T helper cells to recognize the antigen, which in turn activate the B lymphocytes. So these 2 days represent the recognition phase. After this phase, the mouse produces B lymphocytes, which last for 6 days. Then the B lymphocytes almost disappear. But after the second contact with the same antigen after 1 month, that will lead to a secondary immune response, the number of B lymphocytes increases quickly and directly. So there is no recognition phase during the secondary immune response. Why? Because of the memory cells produced during the primary immune response. So the first characteristic of the secondary immune response is that it is fast. Also, we can notice that the number of B lymphocytes produced during the secondary immune response is much more bigger than that produced during the primary one. So, the second characteristic of the secondary immune response is that it is efficient. Also, we can notice that during the secondary immune response, the B lymphocytes remain for 8 days and they do not disappear as in the case of the primary immune response. Then, the last characteristic of the secondary immune response is that it is durable or long-lasting. As a summary for our lesson, the specific immune response is primary if it occurs after the first contact with an antigen, and it is secondary if it occurs after the second contact or more contacts with the same antigen. What are the characteristics of the secondary specific immune response? The secondary specific immune response is fast because it occurs directly by the memory cells, efficient because it gives a big number of effector T or B cells, durable or long-lasting because it lasts for a longer time. At the end, thank you for your attention.